In our fifth video, we're still going to continue our look at the price volatility of bonds, but now we're going to take account of the fact that the relationship between yield and price is not linear. You'll remember from the introductory video that we have a curvilinear or a convex relationship between the price of a bond and the yield of a bond. And so that's quite obvious when you look at that formula. The price of the bond is equal to the sum of the present value of the coupon payments plus the present value of the par, or the principal value. It's quite clear that the relationship between the yield and the price is not a linear relationship because it's raised to the power of time. So clearly it's a non-linear relationship, and we can see from the graph that it's actually a convex relationship. So when we're looking at duration, what we're doing is we're estimating a linear relationship between the bond and the price. So a good way of thinking about that duration is we take the tangent of the actual curved or convex relationship, and the duration is the tangent at the current yield. And so when we adjust the price by a small amount, we can then estimate that tangent line. However, you can see that as we move away, or if the forecast yield increases by a large amount, the further that we move away from 5%, then the less accurate the duration estimate becomes. And you can see that by the gap between the blue line and the black line. And you can see with those arrows pointing to the difference that with the duration we introduce error in our estimate because we're becoming further and further away from the straight line. And so what we need to do is make an adjustment for the convexity of the actual curve. And so that's what we're going to look at next. So our convexity improves our estimate of the percentage price change for the bond when we expect the yield to change. That graph of prices relative to yield is not a straight line, as we just saw on the previous page. It's a convex relationship. And so we can use this convexity for a single bond, or we could use it for a portfolio of bonds or any stream of future cash flows. The convex price-yield relationship will differ among bonds and other cash flow streams depending on coupon and maturity. And convexity. So how do we calculate convexity? Well, in a similar way to the way in which we calculated duration, we find the value of the bond at the current yield. This is V0. We take a arbitrary small adjustment to the delta, so we find a delta y, and we then calculate what the value of the bond will be if the value of the bond rises, so V plus, and we find the value of the bond if the yields fall, V negative. And in this case, the convexity will equal the V positive plus the V negative minus 2 times the initial value of the bond, V0. Divide all of that through by 2 times the V0, and we multiply that by our delta y squared. So to remember this equation, the good way to think about it is that the percentage change in price if the yield falls by delta y is going to be V negative divided by V0 minus the 1, and the percentage change in the price of the percentage change in price if yield rises by delta 0 will be V positive divided by V0 minus 1. The average of these two will then just simply be V positive plus V negative divided by 2V0, and we divide all of that by 2v0. And then further dividing by delta y squared helps us capture that curvilinear relationship. So if we go back to our example that we were looking at before for duration, we take the value v positive, so that's 11,258, plus the v negative, 12,228. All of that minus 2 times the initial value, which was the 11,729, and that equals 28.68. Our denominator is 2 times the original value multiplied by the delta y, in this case 0.5%, and we square it. So our denominator is 0.59. So our convexity will be 28.68 divided by 0.59, and we get a convexity of 48.90. So the duration underestimates the sensitivity of price to interest rate changes due to that convexity. So to get the exact impact of an interest rate change, we have to make that convexity adjustment. So we add that back. So we can use the duration and the convexity to estimate the price. So the dollar change in price can be estimated by the following equation, where we have V0 multiplied by the minus duration multiplied by our change in interest rate. Now in this case, our change in interest rate will be our expected change in interest rate, plus a half multiplied by V0 multiplied by the convexity multiplied by our expected change in yield squared. So therefore, the estimate of the new price is simply what was the original price, V0, plus the change in the price, which we've just calculated above. Alternatively, we can think of it as what's the percentage change in price. So the percentage change in price will be that delta V divided by V0. And that is simply minus duration multiplied by the change in yield we expect, plus a half times the convexity times the change in the expected yield squared. And so then we can find the new price by simply taking the original price multiplied by 1 plus the percentage change in price, which we just calculated above. So in our example, we can find that the percentage change in price, again, is equal to the minus duration multiplied by the expected change in yield, plus a half multiplied by the convexity multiplied by the expected change in yield squared. So in this case, our duration was 8.27. So we take that minus 8.27 multiplied by the change in the yield, 3%, plus a half multiplied by the convexity, 48.9, multiplied by the change in the yield squared. And so we find that the duration effect is that we would expect the value to decline by 24.82 if interest rates were to rise by 3%. But we then have to take account of the duration, which would then add back 2.2%. So we would expect a total change in price of 22.6. So according to the duration, the bond should lose 24.8% of its value. But recognise that we then also have to take account of that convexity, so we would add back 2.2. But if we applied our original pricing formula to the yield to maturity of 11, the bond should be worth about 9,273. So that's a fall of only 20.94%. So to better estimate the value of the bond, we make that convexity adjustment, which is 2.2, and we see that using duration and convexity, we estimate that the price change would be about 22.62%. So by using convexity, we get closer to what the actual percentage change would be. So we see that it's a fair bit closer, but not exactly that 20.9, but we're closer with using that convexity adjustment. So the application of duration and convexity, we use duration and convexity to estimate the price change of a bond. And we calculate our duration and convexity by taking an arbitrary small change in the yield. That allows us to calculate duration and convexity. Then once we've got those durations and convexity, we can say, well, what do we actually expect might happen in the market and how much may interest rates change by? And so then we can use that with the duration and the convexity to figure out what kind of change do we think will happen in our portfolio. And so thus we can use duration and convexity of our portfolio to estimate how volatile is our portfolio going to be to changes in interest rates, and so therefore we might want to change how our portfolio is positioned. So the changes in a bond's price results from a change in yield due to the bond's duration and convexity. So understanding those two factors can help us manage the risk of the bond portfolio. And the relative effect of these two factors depends on the characteristics of the bond, particularly its convexity and the size of the yield change. So one of the things about convexity is that it's quite desirable. So as a bond exhibits more convexity, it'll trade at a lower yield compared to a bond with that of lower convexity. So one of the things we should warn, though, is that obviously duration and convexity has some limitations. As we saw in the previous example, the use of the duration and convexity helps us to estimate the potential change in price, but it's not exactly accurate. But it's obviously better to use than nothing. It is quite difficult to determine the interest rate sensitivity of a bond portfolio, particularly when there's changes in the bond yield. Another caution with using duration and convexity: in this course we're simply looking at bonds where the cash flows are not affected by changes in yield. If the coupon payments are affected by changes in the yield, then we need to use effective duration, which we're not covering in this course. So next we're going to look at credit, and we'll get into some more examination of how credit can affect bonds. Thanks very much.